Okay, now Shiva start.
जी sir. Today's topic is cross tabulation. Cross tabulation, also known as contingency table or cross tab, is a statistical technique used for analyzing the relationship between two or more categorical variables. In a cross tabulation table, the data is arranged in rows and columns, with each cell representing the frequency or count of a specific combination of categories from the variable being studied. Definition. Cross-tabulation involves organizing categorical data into a table format to compare the distribution of variables and identifying patterns, relationships, or associations between them. It provides a way to explore the interactions between different categorical variables and understand how they influence each other.
That's full
Importance
stop.
of
Okay. Now next. Praveen, you start.
Yes, sir.
Importance of cross-tabulation. Read.
Okay. Identifying patterns and relationships. Cross-tabulation helps in identifying patterns and relationships within the data that might not be apparent when examining individual variables separately. By comparing the intersections of different categories, researchers can observe trends and make inferences.
Hey, what happened? Papia, please.
Data exploration. It is a fundamental tool in the exploratory data analysis process. Researchers use cross-tabulation to get an initial overview of the data before delving into more complex analysis. It provides a quick and clear summary of the relationships between variables. Hypothesis testing. Cross-tabulation is often used in hypothesis testing to determine if there is a significant association between variables. By comparing observed frequencies with the expected sequences, researchers can assess whether the relationship between variables is statistically significant. Decision making. In various fields such as marketing, social sciences, and healthcare, cross-tabulation aids in making informed decisions. For example, businesses can use it to analyze customer preferences and tailor marketing strategies accordingly. Policy formulation. In social and political research, cross-tabulation helps policymakers understand the demographic characteristics of specific groups. This information is valuable for designing targeted policies and programs. Quality control. In manufacturing and quality control processes, cross-tabulation is used to analyze defects or issues concerning different product specifications. This analysis enables companies to improve product quality and efficiency.
Okay, now you stop. Now next. Who can? Papia? Hello, Papia.
Sir, actually, I'm on the way, sir. Sorry, sir.
Okay. Poonam, can you start? Hello, Poonam.
Yes, sir.
Please you continue. Clinical research, no?
Yes, sir. Clinical research. Cross-tabulation is crucial in clinical research for analyzing patient data. Researchers can use this technique to explore the relationships between symptoms, treatments, and patient demographics, aiding in the development of effective interventions and treatment plans. Next is identifying risk factors. In fields like clinical psychology and psychiatry, cross-tabulation can be used to identify risk factors for mental health disorders. By comparing demographic information with diagnostic data, psychologists can pinpoint factors that may contribute to the development of psychological conditions. Student performance analysis. Cross-tabulation is valuable in education for analyzing student performance data. Educators can use this technique to compare students' scores based on variables like teaching methods, socioeconomic status, or classroom environment. This analysis helps in identifying effective teaching strategies and areas that need improvement. Next is identifying learning trends. Educational researchers utilize cross-tabulations to identify learning trends among students. By comparing academic performance with variables such as learning styles or parental involvement, educators can tailor teaching methods to better suit the needs of diverse student populations. Early intervention. Cross-tabulation is helpful in identifying students who may require early intervention or additional support. By comparing academic performance with factors like attendance or behavior, educators can detect patterns that indicate students at risk of falling behind academically, allowing for timely intervention strategies.
Okay,
Now
stop
we'll
now.
start.
Stop, Poonam. Thank you. Well
you, sir.
done. Komal, are you here? Hello, Komal.
Sir, yes, sir.
So please you continue from chi-square statistics.
Okay, sir. Chi-square statistics. When you perform a cross-tabulation in SPSS, sir, 1 second, sir. Let me start again. When you perform a cross-tabulation in SPSS and request chi-square statistics, SPSS calculates the chi-square test for independence to determine if there is a significant association between a categorical variables you are analyzing. Here's how to interpret the chi-square statistics in SPSS cross-tabulation. Chi-square value. The chi-square value itself is a measure of a discrepancy between observed and expected frequencies in the cross-tabulation table. A larger chi-square value indicates a greater difference between observed and expected values. Degrees of freedom. Degrees of freedom represents the number of categories minus 1 in each variable. For example, if you are a cross-tabulation tabulating two variables, each with 3 categories, the degrees of freedom would be 3 minus 1 star 3 minus 1 equals to 4. Significance level. The significance value associated with the chi-square test indicates the probability of obtaining the observed data if the variables were independent, that is not related. A small p-value, typically less than 0.05, to suggest that there is a significant association between the variables. Interpretation.
Thank you. Now stop, Komal, stop. Kavita,
Okay,
can you continue from interpretation? Hello, Kavita, are you here? Okay, Nishu, can you continue?
Yes, sir.
Interpretation.
Interpretation. If chi-square is small, that is close to 0, if the chi-square value is close to 0, it means that the observed and expected frequencies are very similar, indicating no significant association between the variables. Second case is if chi-square is large and p-value is small, less than 0.05. A large chi-square value with a small p-value suggests that there is a significant association between the variables. In other words, the variables are not independent and changes in one variable are associated with changes in another variable. If chi-square is large and p-value is more than 0.05. If the chi-square value is large but the p-value is large as well, it indicates that although there is a difference between the observed and expected frequencies, this difference is not statistically significant. In this case, you fail to reject the null hypothesis, suggesting that the variables are independent.
Bah, thank you. Okay. Now I am asking you a few questions. That is, what is called cross-tabulation? You can tell from the note, no problem.
Relationship between two variables.
Okay, Kavita, I understand. Okay. Now you tell me which type of variables will be there in case of the cross tabulation. Metric or non-metric?
Non-metric.
Non-metric or categorical. Correct. Categorical variables. And which statistics we can use in case of the cross tabulation? Probdin?
Non-parametric.
No,
Non-parametric.
Probanin code.
Sir, I
Which,
don't know what to do.
which statistics we can follow in case of the cross tabulation?
I don't know, sir. I don't know what to do.
Just now Nishu read. Okay, Poonam.
The chi-square.
Yes, correct. Chi-square statistics. Now, the chi-square statistics measures what?
Association.
Association,
Between observed and expected frequency.
observed and expected frequencies. Very good. Observed and expected frequencies. And suppose chi-square value is 0. What does it mean?
That observed and expected frequencies are very close, very similar. That the value observed and expected frequencies are very similar.
Similar.
And similar, and there is no association between the variables.
Achha, what is the degrees of freedom? How do you
So that is
calculate the
n,
degrees of freedom?
so that is n minus 1.
N minus 1 into another?
Sir, in row, cell minus 1 into row minus 1, like column minus 1 into
Column
row
minus
minus 1.
1, row minus 1.
Ji.
Achha, significance. What do you mean by the significance?
Sir, at a significant level, when it is 0.05, we expect that 95 and
Your voice is breaking, Shima. Shima, your voice
that
is
the
breaking.
difference is okay.
What do you mean by the significance? When we can think about the significance?
Sir, you are not audible.
What is the meaning of significance? Am I audible now? Hello.
Yes, sir, you are audible.
Okay.
Sir, significance level is the acceptance level.
Acceptance level means
Means on which level we accept or reject the null hypothesis.
okay. And what do you mean by the significance? So when we are thinking about the significance,
The true difference.
no.
Sir, association.
No, Komal. Simple association is not the significance. When we are using the word significance, it carries some meaning. Poonam, can you tell? Significance is used when we are inferencing the sample data to the population distribution. There we are applying the significance. Okay. Is it clear or any question? Any idea about the normal distribution, normal probability curve? Have you seen normal probability curve?
Yes, sir.
What is the shape of normal probability curve?
Bell shape.
It is bell-shaped. Okay. It is bell-shaped. And it is limitless. It has no limit. Normal distribution. It is bell-shaped. And what is the mean of the normal distribution?
Sir, 0?
Correct. Mean, median, mode is 0.
Yes, sir. Yes, sir.
Okay. There is no difference between the two groups. So 50% right side, 50% left side. It is 0. So when we are inferring from the sample data to the population, then we are applying the significance command. We are checking whether it is 0.05 below or 0.05 above. Okay. By the degrees of freedom. This part is clear to all of you?
Yes, sir.
Okay. Now there are a lot of applications of cross tabulation. So can you make any design? For example, there you can find out the relationship between age, gender, and psychological disorder. Okay, so what will be your research design? Age is the metric data. Okay, so you have to you have to classify the age into different categories. Then age will be categorical data. Now, you are asked to find out the relationship between gender and psychological disorder. Okay, then what will be your research design? Very simple.
The
The correlational research.
Hmm?
The correlation research.
Not the correlation. I am talking about the cross tabulation. Suppose you are asked to find out whether the psychological disorders are related to the gender or not. Then what will be your research design?
So that will be hypothesis testing.
Definitely hypothesis.
Analyzing survey data.
How do you collect the data?
The probability sampling. Random sampling.
Yeah, random sample that you can do. Purposive sampling also, no problem.
Yes, sir.
So you have to visit one hospital, right?
Yes.
The Department of Psychiatry first. So you have to visit the psychiatric department, and from there you have to collect the number of psychiatric disorders by male and female. This is very clear. And suppose you have noted there are 5 psychiatric disorders. And you have to maintain some cutoff point. So last 6 months, how many female and how many male came to the hospital for psychiatric or type of psychiatric disorders? And you have noted, okay, 5 psychiatric disorders are very common. Then what will be your cross tabulation? What will be your cross tabulation? Please tell me.
Sir, for male and female. Sir,
Yeah,
for
once
male and
male
female,
and
there
female.
should be and 5 categories of psychological disorder.
So it is 5 by 2.
Yes, sir.
5/2 cross tabulation will be there. And you have noted that is in one cell, the frequency is 2. Okay. Then what will you do? Because in other cells, more number of frequencies are there, but in one cell, frequency is very less. Then for chi-square, you have to do the correction. Okay. Or you have to merge the data with other data. This part is clear to all of you. This is the research design.
Sir, how we do the correction?
There is a formula. You have to follow that correction.
Sir, what is the formula?
In any statistics book, in the book of Garrett or Guilford, you will find.
Yes, sir.
Okay, but in SPSS, there is no problem. You can use the SPSS. SPSS will consider your data.
Okay, sir.
So this part is visible to all of you?
Yes. Yes.
Now this is the data. This is the career impact. Another side is the new strategies. Then new solutions. So they are basically the raw data. Okay. And now I am clicking it, analyze. Then descriptive statistics. Then I am clicking cross tabs. Is it visible to all of you?
Yes, sir.
Cross tabs. Then I am clicking new strategies as the row. Again, one is the career impact as the column. Okay. And there I can write down statistics. So there I am clicking chi-square. Okay. Then continue. Then I am clicking cells. So that is the observed data. I am clicking expected also. And I am interested row, column, total. I want all of them. Then continue. It is written display cluster bar charts. So I am clicking that one also. Okay. So here I get the result.
Sir, the output screen is not visible.
Is result visible? No. This is the result. Okay. So here you can find out 209. And this is the carrier impact. One category, another one, another category, new strategy. So 5 categories are there. 1, 2, 3, 4, 5. Again, there are 5 categories. 1, 2, 3, 4, 5. So 5 by 5 cross tabulation. So this is the cell frequency and expected frequency. All those things are there. Now, here you can find out the chi-square test. Okay. The Pearson chi-square is 68.95 and DF value is 16. Why DF value 16? Can anybody tell me? It is 5 by 5 matrix. So row minus 1 into column minus 1.
Degree of freedom.
Yeah. So that is the degrees of freedom is 16.
Yes, sir.
Hello. And this is significant. So since it is significant, what does it mean? That is, they are associated with each other. And this is called the clustered bar chart. 1, 2, 3, 4, 5. Okay. So there is an association between the 2 categories. This is clear?
Sir, for once, can you show both the variable view screen and output screen together if it is possible?
Follow. It is breaking the voice.
Sir, can you
telling?
the variable view screen once again, and then can we come back to the output screen again?
Okay. This is the screen. This is visible.
Yes, sir.
Here is analyze. And then descriptive statistics.
Yes, sir, I have understood the steps where to reach. I just wanted to see the data once and then I wanted to see the output again.
So this cross tabs is clear to you?
Yes, sir.
Okay. So now you want to see the output.
Out. Yes, sir.
This is the output. So here you can find out the Pearson chi-square is 68.95 and the DAP is 16 and it is highly significant. 0.0001. Okay. So what does it mean? That means these two variables, they are associated with each other.
Sir, but when we were reading the material given by you, it said that if chi-square is small, that is close to 0, then there is no significant association between the variables.
But here it is chi-square is very high, 68.95.
Okay, sir. Yes, sir.
And here
got
you can
confused
find
with the
out
point
these 5 categories are there. Again, the 5 categories are there. And here you can find out there is one data. Okay, that is the 3. I have told you now. That is the frequency is less than 5. So 3, 11, 25, 76, 94. So this is less than 5. Okay, but expected count is this one. So during the chi-square test, possibly it accounts this particular error. Okay, because your frequency is less. Frequency is less than 5. So if you do it manually, then you have to do this. There is some formula, FO minus AP and minus 0.5 something. So 0.5, that is some error. So you have to study the Garrett or Guilford, any statistics book, and there you can find out. But in SPSS, I think there will be no problem. SPSS will consider all of them. Okay, during these results. So this is all about the cross tabulation. Now,
I have a doubt.
now I am presenting you our data. That is this total score and the 2 groups. Okay. So I want to find out these two groups are there. This is the categorical data. And this carrier impact also categorical data. So I want to find out analyze descriptive statistics, frequency descriptives, cross tabulation. So instead of new strategies, I am clicking high and low group. And these statistics, I am writing high also.
So the screen is not visible.
Okay. And the contingency coefficient. Both I have done.
Sir, your output screen is visible. We are not able to see your input screen.
Oh. This is visible now?
Yes, sir.
So last time I have clicked only the chi-square, but not the contingency coefficient and phi. So now I am using phi also. Then continue. And I do not want this one. This row percentage, column percentage, I do not want. I want only the total. Continue.
Sir, there is this command of suppress tables below display clustered bar charts. Yes,
Yeah,
sir. So
that is possible.
what will happen?
Then automatically all the tables will not be there. But I do not want. I want table should be there. So I am getting the table.
Sir, your output screen is not visible.
This is the output.
Sir, your variable view is data view is visible.
Okay, okay. This is clear now? Yeah. So now you can find out the chi-square value. Okay. And why it is 4? Can anybody tell me?
Sir, 3 columns.
It is not
and
16.
rows.
It is 4.
Sir, because we have 3 columns and 3 rows, then 3 minus 1 into 3 minus 1.
How many categories are there? 5. No? So 5 minus 1 means 4. And here 2 minus 1 means 1. So 1 into 4, DF is 4.
4.
Okay. Okay. And now you can find out the Pearson chi-square is 58.68. And here you can find out the phi coefficient, 0.52. Sometimes you have the chi-square, but again, your expert can ask you, so what will be the relationship or relationship coefficient, what will be? Then you have to tell this phi, 0.52. Okay. So this cost tabulation is clear to you? Hello. I think this is clear to you, right? Or any question?
Sir, in starting, you said that if there were not equal data in SPSS, it would take it. So could you like delete some data and then show a practical demonstration of that?
No, here you can find out this, that is 3. Okay, that is less than 5. But if you think about the expected frequency, it is totally 209. 209 divided by 5. Okay, then expected frequency will be less than, will be greater than 5. Then there is no problem. If the expected frequency is less than 5, then you have to think about the error. Or in this case, you can merge this data. That is 3, this 1, only 3 people responded 1. And 11 people responded 2. So you can merge this data, 3 and 11. That is possible. And this is the Pearson chi-square value. And this is the phi coefficient, 0.52. That means these two groups are, they are highly associated with each other. This is clear to all of you?
Sir, why we calculated phi value? So why we calculated the phi value?
Phi coefficient will give you the relationship.
Okay.
Okay. It gives you the relationship, 0.52. It is a coefficient. Phi is the correlation, but this is not the product moment correlation.
Okay.
It assumes that both are the categorical variable. You see nominal by nominal. Then you are considering the phi coefficient. How much the two variables are related with each other. Based upon this, you cannot tell how much the variables are related with each other. You can tell that is, these two variables are associated with each other. But in phi coefficient, you can tell how much. That is 0.52. So moderately, they are related with each other. Okay.
Thank you, sir.
Okay, thank you. Okay, so now I am closing. I will give you the question to the group and please you answer. I have already given one set question, 5 marks. So please you answer them. I think there is no question.